video is going to go into quite a bit of detail, so you might want to pause the video here and there and take some notes. But we're trying to solve this inequality where the left-hand side is in an absolute value symbol. And these are rational expressions on either side of that greater than symbol. First of all, make note of the fact that if we don't have the absolute value symbols, it looks like this is the solution set from this negative 1.243, whatever that is, to 1/2 union the interval from 0.643 to 1. If we include the absolute value symbol, that region right here gets filled in. And here's kind of proof in a table that numbers to the left of negative 1.243, the absolute value of that left side, which this is f of x, and the right-hand side is g of x. This is not greater than g of x, but as soon as I move inside this interval, yes, this absolute value of f of x is greater than g of x, and so on. We move to the right of 1. This is no longer greater than that. So the question is, how could we figure that out algebraically? And one of the things you have to do when you have an absolute value symbol is how to understand how to remove the absolute value symbol. So this expression right here, if it represents a positive number, we can just drop the absolute value symbol and it'll have the same value. But if it represents a negative number, then we have to take the opposite of the expression inside. So we want to solve both of these inequalities. And on the next board, we're going to take a look at what's happening if this was an equal sign. Let's say you were solving this rational equation. You'd make note of the fact that x cannot equal 1/2 and x cannot equal 1. Otherwise, we would be dividing by 0. And then we would clear the equation of fractions by multiplying every term by the LCD of all the denominators, or in this case, cross-multiplying. And we'd end up with this quadratic equation. And if you solve that using the quadratic formula, those are your two roots. And if you graph the function y equals x squared plus 3x, that's supposed to be a minus 4. There are the two roots. That's where the negative 1.243 and the 0.643 came in. And if you notice that this function is negative between the two roots and positive to the left and to the right of either root. And we're going to use that when we start solving the inequalities. So let's work on this one. Here's a little diagram that illustrates what happens if I multiply every term of this inequality by the LCD. To the left of 1/2, this LCD is a positive value. Between 1/2 and 1, it's a negative value. And to the right of 1, it's a positive value. So case 1 says, let's multiply let's let x be less than 1/2. That means I'm multiplying every term by a positive number. So the arrow does not get reversed. So the arrow does not get reversed. I get 0 is greater than that 5x squared plus 3x minus 4. Or this is less than 0. And we saw from the previous board that this function is less than 0 between negative 1.2 and 0.6. But we have to intersect that with the given that we're letting x be less than 1/2. So there's the intersection from negative 1.243 to 0.5. That's where those two solution sets overlap. So there's one solution set. For case 2, we're supposing x is between 1/2 and 1. That means the LCD is a negative number. So we have to reverse the arrow. And this is what we end up with. And we know that this thing is greater than 0 to the right of 0.6 or to the left of negative 1.2. But we have to intersect that with this solution set right here. And that's 0.5 to 1. So the overlap is from here to here, from 0.6 to 1. So there's your second interval. And case 3, when x is greater than 1, we're multiplying, we're not reversing the arrow. So this is less than 0 between negative 1.2 and 6, but intersect that with x greater than 1, empty set. So far we've got these two intervals. On board 2, if we take a look at what happens if we solve this this equation where we've taken the opposite of the expression inside the absolute value, we end up with this after you cross multiply and collect it. And the point is that this expression is always positive. There's the parabola. Okay, so if I want to solve this inequality, the same deal here. Case 1, do not reverse the arrow. We end up with this is less than 0, but we know this is always positive, so empty set. Empty set for case 3 also. Case 2, this expression is always positive, so it's the entire number line, but we have to intersect it with this. 1/2, x is between 1/2 and 1, and there's our 3 solution sets that we have to join together with union symbols. And if we put it on a number line, we can see that the only number that gets left out of this interval, where these are like that, is the number 1/2. There's set builder notation for your solution set right there. Okay, that was a pretty long video. Hope that helped. Pause the video and take some notes if you need to. And if you have any questions, post a comment.